let's assume these are the weights for those that neural network which we already discussed. So this is the input, and the size of the input is the size of our vocabulary we are choosing. So at this point of time, in this particular example, we have taken the vocabulary size of 10,000. Okay, so the size of the input is 10,000 rows and one column. Okay, so this is the size. Now we had 300 dimension of vector embedding. We try to represent each of those words in a 300 dimensions. So our hidden layers will have 10,000 rows and 300 columns. 10,000 rows and 300 columns. For each of these inputs, one neuron. So total 300 neurons, as we have input size of 10,000. So the size of the weights is 10,000 into 300. This is the 10,000 into 300 is the matrix size. Now output will also have a 300 into 10,000 matrix. Okay. Basically, I have written it as 10,000 into 300. So it's okay to understand that for each of the word, as we have total 10,000 neurons in the output layers, and from each of the individual neurons in the hidden layers, we are going to connect to each of those output neurons. So we are going to have a total size of 10,000 into 300 number of weights. Okay, and the matrix size is 10,000 into 300. Alright, now the fun part. How we are going to use that trained or that weights to get the probabilities for each of those individual words to belong as the context word for this target word which we are passing in this input layer. If you remember, I told like the cell which or the position for the target word will have 1 and rest of the vocabularies will have entries as 0. Okay, so again we are taking, suppose these particular positions will have 1 and rest of the things will have 0. Okay, now this particular context in the hidden layer we can term it as the vector embedding or embedding in other term. We can use this input content as the lookup for this vector embedding. Okay, this contains the 300 dimension representation for each of those words in our vocabulary, each of those 10,000 words. This can be used as the lookup to find the vector space for that particular word. For example, if you take this value, if you multiply to this metric or to this vector space content, so you are going to get only one row which will contain 300 values. For example, in this particular case, you are going to get this particular cell which will have 300 different values. You are going to omit or ignore for rest of the content because they have 0 literally. So at the end of this hidden layer or hidden layer weights, you are going to get the values in a 3-dimensional space for the target word. Okay, so what we can take away from here, that with the help of this input data we are going to use it as a lookup for the embeddings, vector embeddings we have in the hidden layer, and we are going to get the 300 or n-dimensional vector space representations for that particular word which we are passing as the target word here in this input. Okay, so at the end of these sections you are going to have a 300 one row which will contain 300 columns. Alright, that is in fact the vector representations of the target board. Now we are going to multiply this 1 into 300 vector with this all 10,000 words, 10,000 content. Okay, for each of these individual vocabulary words, it has some weights. Okay, once we have multiplied each of these rows, you are going to get some values. List of values, basically total 10,000 rows, one column, or one row, 10,000 columns. Okay, then I'm just keeping that metric multiplication context bit away for now. So these 300 rows or 300 values are multiplied to each of these columns, and it will produce some values for each of those individual vocabulary words. And then we'll apply the softmax on top of it. Softmax. Okay, we'll apply softmax on top of it. So finally we are going to get the probability distributions for each individual words. Okay, so the word which will have the highest probability to be the context word will have the highest probability, maybe 9%. This is 0.07, this is 0.02, and the rest will have very little amount of details. So on the basis of this, we can pick up this word as the context word for this target word, or maybe two second context word, third context word. In this way we can find out the related details. Okay, so I'm coming back once again. We are passing as one hot input encoding details for the target word. We are sending those details to hidden layer. From there we are picking out the vector representation for that particular target word. Okay, and we are multiplying the 1 into n or 300 vector dimensional representation to each of these output weights, output vector weights. Okay, we are going to get some values here. Now we are going to apply some softmax, and we are going to get the probability distribution for each one of them. Okay, and this is the whole purpose of this word to vec skip-gram modeling. Alright. Okay, so next we are going to implement it for some simpler document.